Hey crafters, this is Nilton from craftoffprogramming.com. I am a senior electronic trading Java developer based in New York City. So let's talk about Java attributes. But before I dive into it, make sure you watch it till the end, because at the end I'm going to show you how to take advantage of the most useful Java attribute. Let's get started. So let's create the main method here as usual, okay? And let's just grab the a hold of the main thread. Let's pass it to a method that basically just prints the thread attributes, okay? And let's pass the thread here. Let's create our thread, and let's just use a parameter named t. Okay, so let's start printing some stuff here. So let me print the new line character, and the most obvious attribute for any thread, it's obviously its name. Let's get the name of the thread here. So by default, with the exception of the main thread, threads that the user creates, like i.e. me or you, will have the name thread dash then an n, where n starts with 0 and then 1 and 2 and so on, right? This will be the default name that the Java runtime gives to a thread, okay? Another one that is very important is daemon. So let's talk about that as soon as I change this. Is daemon, and it's a boolean. So what is this thing of daemon? So basically the Java runtime uses the daemon property of a thread to determine whether or not it should continue running. So when the last non-daemon thread finishes execution, terminates, then the JVM shuts itself down, right? So as long as there is at least one non-daemon thread running, the Java runtime will continue running. So like I said, the main thread is a non-daemon thread, and one useful property about thread prop attributes is that child threads inherit the attributes from the parent thread. Another one useful is whether the thread is alive, and again is a boolean, and let's just write here is alive. So what else do I have here? ID of the thread, which is an int, the thread ID. Okay, that's another one. So the ID is basically a number. Again, it's assigned by the Java runtime. You really don't have any control over these attributes. Another one that it's super cool is priority. So let's talk about that as soon as I add a thing here. Priority is an int. So if you look at the thread class here, you'll see that the priority ranges from minimum priority 1 to max priority 10, okay? And the default priority is what's called the normal priority value 5. So priorities are an int, range from 1 till 10. The default priority is 5. And the main thread actually has priority 5. So like I said, because priority and attributes of a thread are inherited, the child thread of main, as you will see, will also have priority 5, okay? Now, what is this priority? How can you use it? So this is just a hint to the underlying operating system scheduler to give priority to threads with higher priority when making scheduling decisions. But because this is platform dependent and it's not really bulletproof, you should not really code around priorities. So another one is the thread state. Let's just print it as a string state. And if you look here, let's take a look at the thread state for you to see the values. So it's an enum. Basically, when you instantiate the thread, right, new thread, but you don't actually start it, it's not scheduled to run, it's a new state. So then you've got a runnable state where the thread is pretty much ready to be scheduled by the underlying operating system. A thread can be in the block state when it is attempted to basically execute a synchronized, say, method or block, and it cannot get access to it because that monitor lock is held by another thread. The thread is blocked. And then there are obvious waiting and timed waiting. Waiting is just when you call object wait, and timed waiting is when you call object wait with a parameter, with a timeout parameter. And terminated is the final state of a thread. So let's go back here and continue with the attributes here. Then you have a group, and the thread group is, one very useful attribute. I would argue this is probably the most useful attribute of all of these, because it allows you to assign threads to it and then basically treat all of the threads as a single entity, as a group. And one of the most useful things that you can do with a thread group is assign what's called a default uncaught exception handler, or uncaught exception handler. Speaking of the devil, right, it's obviously the uncaught exception handler, which, like I said, is associated with the thread group. Okay, so that's the uncaught exception handler. And last but not least, something that we developers are all familiar with is the stack trace. Okay, let's see, let's try to find the matching here. And let's do arrays to string. Okay, every Java thread has a stack, and every time you call a method from that thread, it pushes a new stack frame, which is basically, like the method parameters and the local variables and return type. And then what the stack trace is basically so the object, the method names, and the line numbers in the reverse order that the thread actually invoke them. So these are basically all the attributes that we're going to be looking at. So let's execute main so that we can take a look at main's attributes. So if you look here at the console, the name of the main thread, unsurprisingly, is main. Like I said before, main is a non-daemon thread. By the time I printed it, it was alive, of course, and the runtime assigned ID 1. And like I said, default priority of every thread, including main, is 5. It is in a running state. And here is the thread group. The thread group has a name, which is main, and a max priority 10. It has a uncaught exception handler. We will see how to leverage that. And also the stack trace of main. And if you look here, you will see that it started at line 8, and then it called the print thread attributes at line 20. And then I called get stack trace, which is line 1610 on the thread class. Okay, so do you remember what I said about, let's just minimize this when I need it, that all of these attributes are inherited by the child threads. So let's demonstrate this thing here. So first let me create here my thread. Just create a basic thread that we're going to be instantiating it from main, and let's start this thread, and then let's have main join it. Okay, join, waiting for it to die, and join throws an interrupted exception. Let's just put it there. So if you don't know about how to create a Java thread, then please look in the description below, where I have the link to the playlist with all the videos about Java threads. So let's run this. Let's see. So this is the thread attributes of main, and then here is the thread attributes of my thread, right? Because I didn't give it a name, like I said, the Java runtime just assigned it a default name. And notice that the daemonness property has been inherited from main. The ID is just a random number assigned by runtime. Priority again is inherited from main, which is the parent of my thread class, as well as the thread group. You can see name main, the default exception handler, and obviously the stack trace for my thread, right? So now let's see what we can do. Obviously, you do not have to inherit these attributes from your parent class. You can obviously override them and define your own. So in particular, let's extend this my thread here to add support for daemonness. And also let me set the priority to be different, whatever. Let's just set it to max priority. Let me also add a name here to my thread. Alright, so this is the name of the thread, and let's pass the name to super. And here let's set the daemon property, and let's set the priority. Okay, cool. So now I have a way to pass in my own custom name, and whether my thread is a daemon thread or not, and the priority. Another thing that it's important on the daemon property is that you cannot change the D or the daemon property after the thread is created. So if you do that, you're gonna get an illegal thread state exception. So now let's rerun our micro program here and see what we have. So remember, I've set my thread to daemon. Now it's daemon, even though main is still not daemon. I've changed the priority to the max value, Notice that main is 5, okay? And also I've changed the name of the thread, my thread, okay? Okay, so last but not least, let's talk about one of the most useful attributes of a thread, which is the thread group. Now, the thread group is very useful because, like I said, it allows you to assign, say, a uncaught exception handler once, right, to the group, and then each and every thread within the group will actually use that uncaught exception handler. Let me demonstrate here in an example. And what you want to override is the uncaught exception method here, okay? I don't want to call super because I want to, in this example, do my own thing on my uncaught exception handler here. So basically what I want to do, just for the sake of the example here, I just want to print some custom message. So that's a very simple, uncaught exception handler, but it's just to illustrate the example here. And also, I don't need to print these attributes anymore. Instead of just printing the solution is 42, it's actually also, let's change this to a printf because I want to change this to print the thread name. All right, so now when we see in the logs, we will see which thread is printing what. What I want to do here is I want to instantiate my thread group. Let's expand these and add the group as a constructor to my thread here, okay? So notice that there is a constructor that takes the thread group and the name, so that's the one we're going to be using. All right, so now we have a constructor that takes in the group, which is what we want to assign this thread to, because this group has a custom uncaught exception handler that we want to use. So let's now create our 3 threads. Now what I want to do is I want to start them and I want main. So let's just split this up, start, and I want main to join them. There is only one last thing that I want to do, which is, remember, the thread should throw an exception, right? And now here, let's throw our runtime exception, okay? And let's pass in our message. So basically what I'm doing here is I'm just having a thread print solution is 42 along with its name, then sleep for 1 second, and then print again solution is 42 still, and then throw the exception. And then because I'm not catching the exception, and because the thread belongs to a group that has an uncaught exception handler, the group's uncaught exception handler will be invoked, and it's going to print, the exception with name blah, which is was caught by the thread with name, which is one of these 3 guys. Actually, all of them are going to throw. So let's execute this. So let's see what we have here. So the solution is 42, my thread 1, my thread 3. So these are the 3 threads I created. My thread 1 is still saying solution is 42 still, and then it finally slept, and then it threw the exception because the exception is uncaught. The thread belongs to a thread group that has an uncaught exception handler that prints this custom message, okay? And notice that the same thing happened for my thread 2, and the same thing happened for my thread 3. Okay, I hope you found this thread attributes video useful. If you did, then please give it a like. It helps with the YouTube algorithm. Also, consider subscribing to the channel, hit the notification bell. I post videos here almost every day about various Java topics. So now you know about thread groups. Now let's learn about locks and monitors here. Ciao, ciao.